Before we get started, I'm sure you were totally confused by this title here, right? With no context whatsoever. It sounds pretty meta, but what are we really talking about? And I'll just go out and say it that I really hate writing grunt files. I absolutely hate it. Are you guys with me on that? No. Okay, you're trolling me. Are you on the grunt team? Okay. I'm not saying grunt's bad. I'm just saying writing grunt files is absolutely terrible because it feels like our tooling should be smart enough to figure things out, or at least help us along the way. And that really is the goal for this talk, is just to present you with some techniques that we can use to make Grunt just a little bit smarter and take care of a lot of the boilerplate for us. We'll be using Grunt to really just generate Grunt files. Okay. The key things that I want you to take away from this talk is an understanding of Grunt, why we need it to really tame the current state of the front end. And I'll talk about this buzzword, static analysis. How many of you have heard of this static analysis? Right, you're using tools probably if you're a full-time JavaScript developer. You're using tools that use static analysis. Have you heard of JS Hint? Have you heard of JSCS? These are tools that all use this idea. And I'll talk about static analysis, how it coincides with JavaScript, and then really focus in on some of the techniques that we can use in static analysis to make Grunt smarter. And this talk doesn't just apply to Grunt. I'd love to make that statement. It also applies to Gulp, and it applies to Broccoli, but I'm going to focus in on Grunt just to make things kind of concrete. So we begin with the front end, the current state of the front end. And it feels like the Wild West, or it felt like the Wild West. And we're always writing Grunt files, and they might seem like they need to be different for every single application, but hopefully you'll agree with me that there could potentially be a common set of tasks that exist for all production applications. So let's try to quantify those tasks, that set rather. Typically, you're compiling preprocessors. Now, if you're using HTML preprocessors, CSS, JS, doesn't matter. You're typically using Grunt to take care of building out that asset for you, right? Compiling it down into JS, CSS, or HTML. What you're then doing is bundling your JavaScript files based on whatever module syntax you're using, whether it be AMD or CommonJS. And then you're also Bower installing this, NPM installing that, managing your third-party dependencies. You're doing all this manually, but these are pretty consistent. These actions are consistent across all production applications. And then you're doing a few more things here, precompiling mustache or handlebars templates if you're sharing your templates with, between the server and the client. Then you're typically transporting them to the client by way of precompiling them. Validating your code base by way of JS Hint or JSCS. JSCS, if you don't know, is a code style. So typically companies have style guides, and you can enforce that programmatically, which is pretty cool. And JS Hint is just kind of cutting away at quote-unquote bad parts of the language or parts that introduce bugs. You're probably familiar with that. The last thing, but not necessarily the last thing, is you'd like to run your test suite, whether that be for unit tests or integration tests. And this is all kind of consistent across production applications. So we use tools, some of the popular tools, Grunt, Gulp, and Broccoli, to perform these processes for us. Let's focus in on Grunt. And we focus in on Grunt because it is, in fact, the most popular build tool. It's been around for a while. Many of you actually know about Grunt, if not have used it. It's a task runner. And what that means, what a task really means, is it's a plugin that performs some particular task, or performs a job, right? One of our build steps. And that plugin uses configuration options to kind of instruct it what to do about your code base. It's a plugin like Grunt Contrib Sass, which is used for precompiling Sass into CSS, and its configuration object. Really, just to kind of go through this for the uninitiated, we have a very declarative way of saying that this is my Sass compile task or set of configuration. And we're turning globbing on so that we can basically find all Sass files across our entire code base, right? Even within subdirectories. And when this Grunt plugin compiles that Sass file, what it's going to do is stick it into the destination, which is the CSS folder, okay? Here's a Grunt file that you've probably seen before. Okay, this is maybe the seed for all of your Grunt files if you're using Grunt at your company, or if you're going to try Grunt out. To dig into this just very quickly, we have the same compile target for Sass. That's the first point there. And then we have a watch task, and that watch task is basically instructing Grunt. I'll talk a little bit more about the watcher, but basically says, hey, if Sass files change, I want you to execute this particular task, which is the Sass task, that compile task. And then the third step is just loading up all of these plugins. Okay? Very declarative, but this is kind of the smallest set, and this is just for one preprocessor, and it grows. So let's talk about Gruntfiles. Okay? I just mentioned that they grow, and they grow quite quickly. You use Sass, okay, we just saw the Grunt file. You want to use CoffeeScript as well? Well, now your Grunt file gets bigger. You want to use some sort of AMD or CommonJS module syntax and have bundling support? Then you're using another plugin, more configuration. Run your test suite, more configuration. JS hint things, more configuration. Basically, for every step along the way, we've had to go and modify our Grunt file. It is yet another thing to maintain, and it's kind of boilerplate, and that's kind of the emphasis of this talk. All we really want to do is just build our application. We shouldn't have to worry about Grunt, except for my friend here who loves Grunt. Okay? The ideal, in my mind, is that we should just say, Grunt, go for it. Figure out what we're doing, please. Set it and forget it. How can we stop writing these Grunt files, hopefully for good? Let's explore a few solutions that are available to us. One is Yeoman. You guys heard of Yeoman before? Yeah, very popular, free open source tool. And Yeoman is based on this idea of a generator. You can think of it as a command line tool that presents a little survey when it starts up. Right? This is before you start writing any code, it presents a survey that says, hello, and it has a little top hat and all that stuff. And it says, what are you going to use? But it's kind of constraining you already because it's saying, well, hey, would you like to do tests? Of course, because you're shipping production code. So are you going to be using Jasmine or are you going to be using Mocha? Right? It's confining you to a particular set of options. And it assumes that every single application is the same. There are generators for backbone applications and Angular applications, etc. And so this means that every single backbone application will have the same directory structure and the same set of technologies, give or take the choice that you make, within the survey. It gives you the kitchen sink when, in fact, you're not necessarily saying that you want to use all of these tools. And if you, after the survey, decide that you want to add on another technology, you have to go to that Grunt file and modify it yourself. The CLI did its job, the command line interface. So it's not really adaptive to our needs. We should be able to do better than the kitchen sink. But Yeoman works well, right? It does what it does very, very well. And there's a tool that I wrote, which is very experimental. It's called Ya, and it's kind of like Ya Grunt, kind of like a cowboy whipping this beast, this hog beast. So the idea for Ya is that we are going to completely adapt to what you're doing. Adapt to all the preprocessors that you're doing and lazily install and configure Grunt based on what you're doing, right? If you're using Sass, or if you're using less, or if you're using Stylus, figure that out at runtime. In addition, you're writing JS, you're using a particular module syntax. Figure out what that module syntax is, and then figure out how to configure require.js or Browserify. I'll talk more specifically about that. It's pretty cool. By way of knowing what you're using, the tool can generate your Grunt file for you and just maintain it as you continue to develop front-end applications. That's kind of a push toward that ideal of just setting this tool on its way and figuring out everything that you're doing. But if we're not bashing, but just nitpicking on Yeoman and its lack of adaptivity, well, Ya, in fact, is a bit too ambitious. 1 second while my super slow internet connection kicks in. 1 second here. Been having some internet troubles as of late. So it generates and maintains your Grunt file for you. And it's a bit too ambitious in that it tries to tame the entire front end, and that's a really, really hard task. So let's dive in and talk about auto-compiling your preprocessors. And we'll focus in on using Sass and CoffeeScript. The basis for this technique, to instruct Grunt to auto-compile your preprocessors, involves hooking into Grunt's watcher. Okay? The watcher is a plugin, Grunt Contrib Watch, and what that does is it's a mechanism that allows you to observe a directory for changes. Whether you're adding files or modifying files, whether or not files have been deleted, you can be notified of that. And once those modifications have happened, you can say which task or tasks to run. If a Sass file changes on save, we'd like to recompile that Sass file into its CSS equivalent. So what we're doing here is hooking into the watcher, listening for new files to be added. Once we know that a file has been added, let's get the extension. Once we know the extension, if it's SCSS in this example, where we're dealing with Sass files or .sass, there's a finite set of things that we want our build tool to take care of for us. In fact, that's downloading Grunt Contrib Sass, generating that compile task that I showed you earlier, generating a very simple watch task that simply says, when a Sass file changes, please run that compile task. And once you have those two tasks, you have the bulk, you have the meat of your Grunt file. So just flush it to disk, and the watcher, since it's still running, will pick up those changes and now say, hey, I can actually watch your Sass files and recompile them for you. No problem. It should go without saying that this, well, I should say it actually, that it applies to more than just Sass. It applies to less and it applies to stylus. Basically, it applies to any sort of CSS preprocessor. All that's involved to make this technique apply to less or stylus is to simply change the file extension and the name of the library. So for stylus, it's .styl, and it's probably Grunt Contrib stylus, but the same steps apply. Now let's talk about CoffeeScript. Same technique. We're looking for a particular file extension, .coffee. And again, very, very similar set of steps that need to take place. npm install grunt contrib coffee, generate a compile object here that says, hey, look for all CoffeeScript files and compile them, and here's where you store the JS compiled output. Here's the watch task. And then once you have those two again, you can lump them together with the Sass configuration that you generated in the previous step, and now you have this bigger grunt file, and you just flush that to disk, again, updating the watcher to understand how to deal with CoffeeScript files. It also applies to other JS abstractions, where you have TypeScript, ClojureScript, etc. You're not limited, per se, to what a CLI tells you. You are limited to what Grunt has a plugin for, and there are thousands upon thousands of them, which is kind of awesome. This is some code to show you what hooking into the watcher looks like. It's a custom callback on the watch event for Grunt. All we're doing here is saying if a file was added, just broadcast out to Ya that this particular extension was added. And Ya then takes care of npm installing the appropriate library, generating the compile target, and it knows what to do because it's boilerplate. Okay? And that's kind of the point. It's complete boilerplate here. So that's a configuration for Ya. It's a settings for Sass on the left. It says, hey, here's the library that you should install when the SCSS extension gets added to our code base. And the inner object of the target there, that Sass, compile, etc., that's what should get dumped into the Grunt file. On the right, you have what looks to be the exact same thing minus the comment differences. Just changing the extension to .coffee and changing the name of the plugin that you should install. This is what our Grunt file looks like so far, and it's a little truncated just because of space constraints. The first point identifies the Sass and the coffee compiles configurations. Then you have the watch configuration for Sass, and it's almost identical for CoffeeScript, except for the extension. That can just be generated for you automatically. You can start using Sass and CoffeeScript today without actually writing a Grunt file. That's fantastic so far. And then you throw Compass into the mix. And if you haven't used Compass, it is this Sass framework that most notably introduces mix-ins. Okay? And when you throw Compass into the mix, your configuration your predetermined settings actually becomes dynamic. It's not so straightforward anymore. Two things have to change. One is the choice of the plugin that you're going to use. Before we said when it was just pure Sass, it was Grunt Contrib Sass. But now, if Compass was installed, we use Grunt Contrib Compass. And Compass being a superset of Sass, it will work even if you're not using mixins. Okay? But you have to be able to detect that at runtime. The second thing that changes is the compile configuration, the compile task. And that's mainly because Compass has something known as a generator where it can say, hey, would you like to separate out the Sass from the compiled output into separate directories? If so, well, Compass lets you do that. And so our tooling should respect that instead of just dumping everything, both Sass and CSS, into the Sass folder. You guys with me on that? Yeah? What we've achieved with this technique is the ability to use a CSS preprocessor and not write a grunt file. Let's get to the good stuff. This is where it gets pretty hairy, pretty technical, but this is, I think, the most interesting part of it. Having our tooling auto-bundle our JavaScript applications without us having to write any tooling for it or configuration. Never again will we have to write something like this, and this is the most infuriating part of using Grunt for me. It's that include, the first point there. It's like, what is your entry point? And I'm like, are you serious that I still have to specify what the entry point of my application is? Come on. We are pretty advanced here. Why do we need to do this manually? And the output itself, most often I don't really care what the name of the output file is. So long as I know what the name is, I can include it in my HTML. All is well. So that's the goal, is to never again have to write this. We use the same technique for one part of this. The technique of being notified when new files get added. What we care about now is the .js extension. Okay. When we get a new JavaScript file, we want to do several things here. The first thing is determine what the module syntax is. Okay. You have a file, JavaScript file. Is it in AMD or is it in CommonJS? That's really important because it influences the plugin that you use. Okay. If in fact if it's AMD, you use Grunt Contrib Require JS. If it's CommonJS, you use Browserify. Okay. Once you know which plugin to use, it's a matter of generating the appropriate configuration for that plugin. You need to determine automatically, programmatically, what the entry point is. You should never again have to specify what that input, what the starting point is. We call that the root. And then for the output, you should just auto-name it, right? And tell you what the name is, so you can just include it in your HTML. That's the bundling task. And now you need a watch task that says, on change of a JS file, just rebundle, please. Similar to our preprocessor case, once you have the bundle task for Require JS or Browserify, and you have the watch task, you have the guts of your grunt file, flush it to disk, the watcher updates in real time, and now knows how to deal with your JavaScript. Don't have to touch the grunt file. So let's dig in to some of the key points here. How do you detect if a JavaScript file is in AMD or CommonJS format? Well, to do that, we use static analysis. I'll define what static analysis is. In the JavaScript case, we're specifically using a tool called Esprima to achieve this. Static analysis is actually pretty straightforward, even though it sounds cool, and it is cool, but it's easy. Okay? All you're doing is taking a JavaScript file, you're piping it into Esprima, and what you get as output is what's known as an abstract syntax tree, which I know sounds incredibly fancy. Forget I even said the word. We just call it ASTs. Look at it. There's nothing really special here, even though it's some funky words like call expression and array expression. We'll get to those. But it's just JSON, right? It's just a JavaScript object. That's it. Input is a JavaScript file. Output is a JavaScript object that formally describes what that file is doing, what the code is. I'll dig into the AST a little bit in a few slides. Static analysis, Esprima specifically in the JavaScript case, is used in many places and in many tools, JSHint, JSCS, JSDoc, and as I checked the numbers not so long ago, about 533 projects depend on Esprima. So it's pretty widely adopted. Okay. So we know that we need to use Esprima, give it a JavaScript file, and it should be able to, or at least we should write rules that tell us whether or not a file is in CommonJS or AMD. And we use the AST for that. So just to get a feel for what the rules look like, a file is in AMD syntax if it has a define function call. Okay. Or it has a top-level require, and that's a require function call that's at the very top of the file. See some examples. AMD is pretty peculiar in that it has 4 different syntaxes for how you use the define function call. Okay? So it's not just a define function call. It's, in the first case, a define function call that has a string argument as the first argument, and then an array of dependencies, and then a function. Or in the second case, it has no name, no string literal as its first argument. Or it uses kind of a CommonJS style of import where you have a factory function that takes in a require statement, or it has no dependencies whatsoever and it's just an object singleton as the first argument to the define function call. So that's the first part of that condition there, the has define. If it can find any one of these forms, it's AMD, or if it's the special case. And this special case, if you haven't seen it before, it's typically the entry point to your application. This is where you say like, okay, this is my bootstrapping point, time to pull in all these things that I need just to get going. And then your application has taken over. Let's talk about CommonJS. CommonJS is, a file is in CommonJS if in fact it has an exports statement, or if it has a require function call. But hey, that sounds very, very familiar. There are some ambiguities, there are some conflicts between CommonJS syntax and AMD syntax. We have to write rules that allow us to avoid those conflicts. So if it has a require, but it does not have a define, and basically that clause there is used for that third case, where if you look at the inner part of that function, you have var a equals a require function call, and you're passing in this string, right? So it's a require call, which looks a whole lot like CommonJS. Specifically, the last case there on the right, you have a require call. If you look at that, it's the body of where the arrow is pointing to. So you need to strengthen your rule to disambiguate. Okay? Now that we have a rough understanding of what it means to be in the AMD or the CommonJS syntax, programmatically speaking, let's see how we can use a very, very simple JavaScript module. And what syntax is this in? AMD, right? You can tell immediately, but we need to write rules that assert that this is in fact in AMD syntax. Given this AST here, and this is really a small form of the entire AST here, this is focusing in on the really interesting part, the really core part to it. Can we write an assertion, right? We know that this is the AST for that JavaScript file there that we know is in AMD syntax. Can we write rules that say, given this AST how can we match it to any other node in our file? Meaning, given any other file, can we run a set of assertions to determine if it's equal to this AST here that we know corresponds to an AMD file? This is one type of assertion. Okay? This detects whether or not an AST is a defined function call. Looking at the body very quickly, we have node type equals call expression. And if you go to the right, we're looking at the first point there, node type is in fact a call expression. Okay? Is the callee's type, if you look to the right, you have the second point here where it's the node's callee, and the inner type attribute has the value identifier. And is the callee's name defined? Well, really, this AST looks a little bit cryptic, but what it's saying here is that there's a function call going on, and the function that's being called is this identifier with the name define, right? It's the word define being invoked. That's what the AST is saying. And so we have there an assertion that can tell whether or not a node is in fact a defined function call. Okay? And there are some tools. AMD gets no love in the node community. RJS for required.js is like the only thing that exists, and not much else. So for a lot of the AMD-centric work in making Grunt smarter, I've had to create a lot of libraries there, so you can take a look just to get more detail if you're interested in what the code looks like. Okay, what we've been able to do is write assertions that determine whether or not a file is in CommonJS or AMD syntax. That influences which plugin we use, whether it's Grunt contrib required.js or Grunt browserify. The next point is to determine the entry point to your application, right? So we don't have to write it anymore. We call it the root. And the root, just to define what a root is a file that no other file depends on, no other file requires. And if we look at this little tree structure here, the root should be clearly visible. It's F, right? If in fact those arrows represent that F requires B and F requires G, but no other file requires F. F is a root. F is an entry point to our application. Alongside that point is an entry point to our application corresponds to, in fact, a bundle. So every root in our code base should be a separate bundle. There are exceptions because a grunt file could technically be called a root, and we don't want that being used anywhere else, right? So we might have to ignore that specifically. The algorithm for determining what the root is, given a series of JavaScript files, is you go across all of these files. And what you're doing here is maintaining a list of what's been required. You're maintaining a list of all the dependencies. So for every single JavaScript module, for every node there in that tree, what you're doing is grabbing its dependencies. And you do that via what's known as a detective. And Substack has written a detective for pulling out the dependencies in a CommonJS file. And I've written one for the AMD syntax as well. So you have the ability now to identify the dependencies within AMD and CommonJS. For each of those dependencies, you mark them as used. They have been required by a file in our code base. You do that for every single file. At the end of the day, at the end of this whole process, the files that are not in that list of things that have been required, they are roots. And hopefully you're with me on that point. Again, a root is a file that has not been required. And there are some tools to help. So what our grunt file looks like now, given our static analysis approach to auto-determining the module syntax, hence the plugin, and the entry point of the application. Looking at the first point here, we have a required.js task, and then we auto-generate the target name for Grunt. We really don't care what it's called. It could be called bundle even, the T0. And the options are the most important. The third point there is, in fact, the entry point. This is the starting point for our code base. And then we auto-generate the name for the output file. Similar approach happens for browserify. Okay? Similar configuration. Then we have our watch task here, which quite simply says, look for every single JS file in our code base. But you don't really want to do that. And the exceptions are quite important. For example, you don't want to look at the grunt file because that could be considered a root. You don't want to look at all of the third-party dependencies like jQuery and Backbone and so forth that you're using. There's no need for them to be deemed as roots. Okay? Once a JS file has changed, you want to rebundle it, okay, using our required.js task. All right. We've spoken about taking care of our preprocessors. We've spoken about auto-bundling our JavaScripts, no matter which syntax you're using. Of course, if you're not using AMD or CommonJS, I cannot help you. Okay? Please use one of them. You should be, otherwise you're dealing with like massive amounts of script tags. In any case, what about the other tasks that defined the current state of the front end? What can we do about those? Given this idea of static analysis, given that we can find out and assert properties on the AST of a given file, we should be able to precompile templates using a similar approach to Sass, CoffeeScript, etc. If the newly added file has the .mustache or the .handlebars extension, well, here's the plugin that you should download. And then watch all of the files across the directories that have that extension and rerun this task. Very, very similar to Sass, CoffeeScript, etc. For validating our code base, look for a .js hint RC, look for a .js CS RC, download the appropriate Grunt plugin, and run that every single time a JS file changes. Running our test suite can use a bit of static analysis there, where we look at a JavaScript file, and it has the .js extension, so we can't use that trick. What we have to do is look into that JS file, observe its AST, and look for its function calls, or describe function calls, if you've ever used, let's say, Mocha or Jasmine. Managing vendor dependencies is kind of interesting, and that's where it gets non-trivial. Well, in a simple case, you could just look for an identifier that is a $, or you could look for an identifier that is the word jQuery. That's a good guess that you're using jQuery, and so your tooling should just npm install jQuery. If you have the word backbone, good idea that you're using backbone, right? Auto download and configure that, or just download it really. But what about files that are not in AMD, not in CommonJS, that are not on NPM, or that use UMD or something like that, right? These files that have to be shimmed. That's not so straightforward. My point is to show you that it's not just black and white with this, that it gets a little hairy. 1 second, I'll get to your. So we can see that we can use these techniques to tackle the rest of the front end. And that shouldn't be the final list, right? It's a matter of exploring now all the steps that we're taking in our production applications and trying to apply these techniques. So what do we do next? What should we be using now? Well, you could use Ya, and I'm telling you not to, because it's experimental and it's trying to do too much, and it's really just an exploration of whether or not we can actually automate generating grunt files completely. How far can we take that? And I'm not sure that one tool to rule them all is in fact the answer. So can we build these ideas into the tools that we use, into the bits and pieces that we're using to take care of our front end? Can we build this idea into grunt contrib require JS to auto-determine what the roots are? Can we build it into Browserify? What's really exciting is that Gulp can also use these techniques, and Broccoli. And imagine having Gulp generate its own Gulp file. Gulp is super fast. And with Grunt specifically, I've had to do so many optimizations just to get it to not slow down to a halt when observing the entire code base. You can use things like Newer, etc., all these different plugins to optimize, but it's a headache. The point is, let's take the grunt work out of using Grunt. Let's let our build tools take care of building without configuration. Thank you. You had a question?
Yes, we run into some problems with a Gruntfile versioning.
So the question is, how do you deal with versions of your dependencies? And that's a hard one. It's not safe to just say, well, always grab the latest. The ideal of having a tool not need any configuration, and for Ya, just to give you an example, all you say is, here's a directory, do what you need to do. You never have to provide configuration, but that's not going to work, especially for your case, right? There has to be some sort of configuration, but then do you define that for every single vendor dependency that you're going to use? That's where it gets kind of difficult, and if you're doing that, you haven't achieved much of anything. So it's a hard point. So currently, the question is, the grunt file that's generated, can you make alterations? Currently, the tool just says you shouldn't have to, so it will completely blow away all of the alterations and it will regenerate your grunt file. That's not great, and I think a better approach is to hold the configuration in memory, alter it there, and try not to destroy the grunt file because it's a hard problem. And you're not going to be able to solve all of it with one tool. So you should be able to make alterations and not have the tool affected from being able to recognize what you're doing. And if you're using custom plugins, I think one approach is to use Sindre Sorhus's task, which is the load all task. I forget the name of the plugin, but it allows you to avoid saying load this particular task and this and this and this and having a huge stack of them. You can just say load all the tasks that are currently present. And so if you want to alter the Grunt file, what you could do is have a custom Grunt plugin that also gets loaded up and potentially executed outside of that main Grunt file. So the point is, so your point that you're making is, in fact, you lose a bit of documentation, an understanding of what the process is. That's a good point. I'd love to talk about it further. You still have the Grunt file on disk, and you can look at it, but it's not annotated with your own custom thoughts. Again, I think the Grunt plugin approach is kind of like there's this brain here, and there are things that should happen on the side, and they can ever so non-invasively hook into that brain using the load all grunt tasks plugin, right? So I think you can still achieve it while keeping the core common set automated, fully automated. Question?
So where's that bit?
So the question is, how does a tool like YA know what to do when
Where to start? What to look for?
What to look for, exactly. So you can get the extension based on that custom callback to the watch event, right? You can get the actual extension, and YA itself has just predetermined settings for a bunch of popular preprocessors, and it has settings for require.js and browserify. And so it can, in fact, based on the file extension, determine what to do. I think a better approach, though, is to not have to manually add new settings, right, to make the box bigger of things that you could potentially be using, but to maybe even carry out a search, right, to Grunt's database of plugins, and then do some sort of fuzzy match to vote on what the best plugin or most appropriate plugin might be. So currently, it's coded, and it's very easy to drop in new settings to further expand your tool set, but I think there is hope for a better solution where you can just search for the appropriate tool. Does that answer your question? Yeah, cool. All right, so I will be available to chat. I'd love to talk about this stuff. This is not an answer, just more so of a poke at a question. Thank you guys so much.